While Kevin was firing red bricks, we noticed that he collected the wood ash. This is actually a key ingredient for making cement in the wild. We already know that making charcoal involves blocking the fire from burning the wood completely, where the material does not touch an open flame, to achieve a similar result. Do you think replacing the chicken with wood could produce the same effect seen in the video? Let's get right to it. First, we will prepare a clay pot that did not cost any money. In a few days, I will update the video on how to make these pots. Once the wood is placed evenly inside, we turn it upside down in the stove. Then, the bottom is sealed up. This prevents the flames from entering the pot. Using bricks to build the structure is best. The stove can then burn wood inside, providing a continuous source of high heat. Since pottery has lower thermal conductivity than a metal drum, it takes more time to heat up. Longer burning is required for the wood to carbonize directly. This process needs to continue for 2.5 hours. Extinguish the fire. Now, let's open the clay pot and check the results. The wood has been carbonized perfectly. From the look of the surface, I believe this charcoal is even better than what we made before. Even though a few pieces did not carbonize fully, it does not really matter. They are not the main focus today. Our focus is on this humble ash. Its main component is potassium carbonate. The rest consists of insoluble silica and calcium carbonate. We will only take the finest part. After adding some river water, we shape them into small round balls. Place them near the stove to dry. Actually, before this step, we could use water to wash away the potassium carbonate. It is considered an unnecessary impurity. However, Kevin skipped this step. This will not have a significant impact on the final result. The next step is to fire them at a high temperature. To ensure the effectiveness of this step, he specifically set aside one unburned ash ball. High temperature firing allows the calcium carbonate inside to convert into calcium oxide. At the same time, it burns away any remaining charcoal. Take out these glowing red ash balls. After they cool down, mix them with water. The principle here is that calcium oxide creates calcium hydroxide. This wood ash cement does not have any extra additives. For an easy comparison, he found some discarded red bricks in pottery. He crushed them into a fine powder. Then, he mixed them in different ratios to see the results. This is a 1-to-1 ratio. Do not ask me which one is better. This piece is a mixture of lime and brick dust at a 1-to-2 ratio. This one is definitely a 1-to-3 ratio. Adding too much brick dust will prevent it from bonding. These are all the samples. The one that was not fired looks like a simple mud ball. The fired ones look very hard. After letting them harden for a full week, Kevin finally placed them in water. This is a solubility test. Let's give them enough time to see if they work. We gave them a chance, and now it is up to them to hold together. It is quite clear. The one that was not fired did not hold up at all. However, the other samples with the correct ratios remained perfectly intact. This demonstrates the importance of the firing process. You should not worry about how hard it is. When you are in the wilderness, you cannot be too picky. But I have to ask, for this kind of cement, is there a difference between using brick dust and sand? After all, in our daily lives, sand is much more common. He fired another batch of wood ash. Half of it was mixed with sand at a 1-to-3 ratio. The other half used the same ratio, but was mixed with brick dust. Let's see which one is stronger. We will give them 2.5 days to harden. Then, we put them in the water again. This is another solubility test. After 24 hours, all the samples are still intact. At least they look the same on the surface. However, according to Kevin, the sand mixture is easier to scratch. Its strength seems to be a bit weaker. So, if you ever find yourself stranded on a deserted island, do you know how to build your own concrete house now?